Okay, in this video, it's a pretty long one, so let's just get started. Gas laws. We're going to be talking about the different gas laws that exist. So we're going to go through each one. We're going to do a couple practice problems, and we're going to see how they're involved in volume, pressure, and temperature. So first one is Boyle's law. Boyle's law is when volume and pressure are inversely related. So in your notes, make sure you write the word inversely. And here's the formula that you need to write down in your notes. That word inversely means as the pressure goes up, the volume goes down. And so P1, V1 is going to be the initial pressure and volume. P2 and V2 are going to be the final volume. So looking here, if I squeeze this down, I'll have a high pressure because those molecules are going to hit the walls a bunch of times, but it's a small volume. Over here, the volume's bigger, but they're not going to hit as much. So no pressure. So let's see how it looks in an actual problem. So in this problem, it says a sample of hydrogen changes its pressure from 756 torr, well, that would be pressure 1 because that's the first pressure, to 499 torr, that would be pressure 2, while the temperature remains constant. After the pressure is reduced, the volume of the gas is 789 milliliters. It says after the pressure is reduced. So this is going to be volume 2 then. What is the original volume or volume 1? So I'm going to write my formula. P1V1 equals P2V2. I want to know what was the original volume. What was volume 1? So in order to solve, I'm going to divide both sides by pressure 1. And then I'll get this formula. Volume 1 is equal to P2V2 over P1. So now this is the equation that I'm going to use because it's rewritten. So when I set up a table, I'm going to put pressure 2 here, volume 2 here, and pressure 1 at the bottom because I'm dividing by it. So pressure 2, I said, was 499 torr times volume 2, so that's going to go at the top, 789 milliliters, divided by pressure 1, which was 756 torr. All right, so looking here, torr is going to cancel out. So I'm left with milliliters, so then I'm just going to multiply and divide. 499 times 789 divided by 756, and I got 521 milliliters. And that would be the answer right there that I'd be looking for. So as you can see, the original volume is less because it has a higher pressure. So looking at this problem, similar, a gas is known to have a volume of 7.81 liters, that's volume 1, when the pressure is 754 torr, that's pressure 1. What would be the pressure in ATM if the volume changed to 9.21, so this is volume 2 this time, and the temperature is held constant? So let me write my formula. I am missing pressure 2 this time, so I'm going to divide both sides by volume 2 so I can get pressure 2 by itself. So P1V1 divided by V2 is equal to pressure 2. Plugging it in, starting with pressure 1, it is 754 torr. Volume 1 is 7.81 liters. Volume 2 is 9.21 liters. Liters cancels out, so my answer is going to be in torr, but they don't want my answer in torr because it says, what is the pressure in ATM? So I'm going to have to change it. Even though I have torr left over, I'm just going to do one quick conversion, and I'm going to change it from torr to ATM. This is the number from the last video, so ATM will always have a 1, and torr will always be 760 whenever I'm converting. Now I'll plug it in. 754 times 7.81 divided by 9.21 divided by 760, and I got 0.844. 0.844 ATM. And that would be the answer right there for this problem. So the next guy we have is Charles' law. This one's a little bit different because it says Charles' law is volume and temperature are directly related. So as the volume goes up, the temperature should also go up. They are directly related. So there's my formula. V1 divided by T1 is equal to V2 divided by T2. Looking at this problem here, I'm going to start labeling. A 5.2 liter, that would be volume 1, sample of gas is heated from 25 degrees to 100 degrees. So this would be temperature 1. But you have to remember, we are never going to use degrees Celsius in this unit. You will always have to change it to Kelvin. And so to change it to Kelvin, remember I'm going to take 25 and I'm going to add 273 to it. And that's going to give me 298 Kelvin. So this is the number for T1 that I'm going to use. It's heated from that number to 100 degrees Celsius. Same thing. My T2 this time, I'm going to add 273. So it's going to be 373 K. What is the volume at the higher temperature of if the pressure remains constant? So let me write the formula. V1 divided by T1 is equal to V2 divided by T2. They want to know what's this volume. So what's this right here? So I'm going to solve for this, I'm going to cross multiply and then divide. So I do the cross first. That'll be volume 1 times temperature 2 divided by whatever's on this side except for what I have circled. So it's going to be divided by T1 is equal to what I have circled, volume 2. So there's the formula I'm going to use. You can never have temperatures next to each other because then they won't cancel out. So you should at least know that one has to be on the top and one has to be at the bottom. So making a table, it's going to be the same thing. Volume 1 at the top, 5.2 liters, times temperature 2, which was 373 Kelvin, divided by temperature 1, I'm going to put it here so the temperatures are aligned, 298 Kelvin. Looking at my units, Kelvin cancels out, so I'm left with liters. I'm going to multiply and then divide 5.2 times 373 divided by 298, and I get 6.5. And there would be the answer for this one. In this one, it's a little tricky because it says a gas is found to have a pressure of 700 torr. So they give me a pressure here, pressure 1, at a temperature of 54 degrees Celsius. So this is temperature 1, but remember, I have to add 273 because it is in degrees Celsius. So 273 plus 54, I got 327 Kelvin. If the volume of the gas under these conditions is this, 3.21 centimeters cubed, that would be volume 1. What is the original temperature when the volume was 2.81 centimeters cubed? So there's another volume, volume 2. And the pressure is 700 torr. If I look, this pressure is the same pressure as the pressure 1. So since they're the same, I can ignore pressure. I can pretend it's not there because it's not going to affect my answer. So let me write my formula. V1 over T1 is equal to V2 over T2. This time I'm missing temperature 2, so I'm going to circle this one. So I'm going to cross multiply. I'm going to do the cross first. So it's going to be volume 2 times temperature 1 divided by whatever's on this side. So divided by volume 1 is equal to temperature 2. So I just plug it into the little table here. Volume 2 I said was 2.81 centimeters cubed. Temperature 1 I said was 327 Kelvin. And volume 1 was 3.21 centimeters cubed. Well, looking at this, centimeters cubed will cancel out. So I'm left with Kelvin, a temperature for my answer. I'll multiply 2.81 times 327 divided by 3.21. And I got 286. So that would be the new temperature right there. So we're moving on. We have Guy-Lussac's law here. In Guy-Lussac's law, that's when pressure and temperature are directly related. And so if they're directly related, I know that the pressure goes up, then the temperature also goes up. And there's the formula for it. P1 divided by T1 is equal to P2 divided by T2. Let's see how it works. What will happen to the temperature of a gas in a rigid container if the pressure is increased 1.65 times its original? So that means that the pressure increased by 1.65 times the amount. So the temperature we said was directly related, meaning if the pressure goes up, the temperature goes up as well. So since the pressure went up, the temperature should also go up by 1.65 times the amount. The exact same rate because it is directly related. So that would be the answer for this one. All right, so for this one, they give me numbers. So they want me to calculate something. They say a gas at 222 torr, that's pressure 1, and 21 degrees Celsius, that's temperature 1. So add 273 and I get 294 Kelvin. Is heated and the pressure is changed to 247 torr. So that's pressure 2. What is the new temperature? So let me write the formula. P1 over T1 is equal to P2 over T2. They want to know what's T2, so I'm going to do the cross first. Pressure 2, temperature 1 divided by this one. Pressure 1 is equal to temperature 2. Plugging it in, pressure 2 I see is 247 torr. Temperature 1 I said was 294 Kelvin. And pressure 1 is 222 torr. Looking at all of my numbers, torr cancels out, so I'm left with K, which is Kelvin at temperature, which is good. 247 times 294 divided by 222, and I got 327. There's my temperature right there. All right, so remember, on the test, you don't have to memorize all of them. You just need to know how to use them all. So in here, I'm going to show you how to remember them all with this one, the combined gas law. It is basically a combination of Boyle's, Charles, and Guy-Lussac's law. And so there's a big equation that has all three of them in it right here. So P1V1 divided by T1 is equal to P2V2 over T2. You can get all the laws. So if I don't look at the T's, I see it's P1V1 equals P2V2. That's Boyle's law. Or if I ignore the pressures, volume 1 divided by temperature 1 is equal to volume 2 divided by temperature 2. That's Charles' law. And then the last one, pressure, temperature, that's Guy-Lussac's law. So let me show you how to use all three of them together. What would be the volume of a 8.90 liter, so that's volume 1, sample of gas at 100 degrees, temperature 1, which is 373 Kelvin, and 113 kPa, that is pressure 1 right there, if the conditions were changed to STP. If you don't remember what STP stands for, it's standard temperature and pressure. We talked about it in the last video. The standard temperature is 0 degrees Celsius, or I have to change it to Kelvin, 273 Kelvin. And so this is going to be my T2. The pressure can be any of the pressure conversions that I have, 1 atm, 760 torr, 760 mmHg, or 101.3 kPa. I can pick any of them. Since pressure 1 is already in kPa, I'm going to pick the kPa one, which is 101.3 kPa is equal to pressure 2. And so let me write the formula that I have, the combined gas law. I have every letter in this right here. If I look, there's T2, P2, P1, T1, V1. I'm missing volume 2. So don't worry, I'm still going to just cross multiply. So I do the cross first, and that's going to be pressure 1, volume 1, temperature 2. And I'm going to do this cross divided by pressure 2 and temperature 1 is equal to what I have circled, volume 2. So now I'm just going to plug them in like how I see it on the table, and then that'll be my answer. You just have to make sure you have everything labeled correctly. Pressure 1 I said was 113 kPa. Volume 1 I said was 8.90 liters. Temperature 2 was 273 Kelvin. Pressure 2, I'm going to put it over here so they can be on top of each other, 101.3 kPa. And temperature 1 I said was 373 K. Looking at my units, kPa cancels out, K cancels out. My answer's in liters then because that's the only unit that's left. I'm going to multiply and then divide 113 times 8.90 times 273 divided by 101.3 divided by 373, and I got 7.27. 7.27 liters. And there's my answer right there. All right, in this video, it says, in this problem, it says a 1.50 liter, so that's volume 1, sample of gas at 5 degrees Celsius, that's temperature 1, add 273, and I get 278 Kelvin, and 77.7 kPa, this is pressure 1, is heated and expanded to a new volume, 1.83, that's volume 2, and 615 mmHg, this is pressure 2. What would be the temperature of the gas in Celsius? Oh, so they're going to have us do a bunch of problems in this one. So first things first, let me write the combined gas law. Looking at these problems, I need to first figure out what am I solving for. I'm looking for temperature, the new temperature, so that's going to be temperature 2. I'm going to cross multiply, so the cross goes first. So P2V2 over T1. Then I'm going to do this one, which is P1V1 is equal to temperature 2. So I just need to plug it in now. Pressure 2, I said, was 615 mmHg. Volume 2, I said, was 1.83 liters. Temperature 1, I said, was 278 Kelvin. Pressure 1 was 77.7 kPa. There goes my two pressures. And last but not least, volume 1, which was 1.50 liters. If I look at my units, liters cancels out, but that's it. So as you can see, I still have 3 different units. Well, I want to get rid of the pressures, so I only have temperature. So I'm going to do one more step. To get rid of kPa, I'm going to put it on top. I'm going to put mmHg at the bottom. kPa on the chart was 101.3. mmHg was 760. So now mmHg and kPa will cancel out. All I'm left with is Kelvin, so I'm going to solve first. 615 times 1.83 times 278 times 101.3 divided by 77.7 divided by 1.50 divided by 760. And that equals 358 Kelvin. That's not the answer though, because they don't want the answer in Kelvin. They say Celsius specifically. So to go from Kelvin to Celsius, I'm going to subtract 273, and I get 84 degrees Celsius. And there's my answer right there. Or you should try pausing the video and try doing this one by yourself. Okay, I'm going to go fast through this one. This would be volume 1. This would be temperature 1. I add 273 to it, and I got 368 Kelvin. This would be pressure. Oh, snap. This would be pressure 1. It's placed in a 15 liter, volume 2. This would be temperature 2. 80 plus 273, and I got 353 Kelvin. What is the new pressure? So we'll write the combined gas law. You should have did this already. You're looking for the new pressure, so pressure 2. So I'm going to cross multiply first. P1V1 T2 divided by, then I'll do the other cross. Volume 2, temperature 1 is equal to pressure 2. Plugging it all in, starting with pressure 1, I got 760 torr. I got volume 1, which was 18.2 liters. Temperature 2, which I said was 353 Kelvin. And then volume 2 at the bottom, which we said was 15 liters. and temperature 1 at the bottom, which was, oh shoot, no, this was 368 Kelvin. Okay, so good. Looking at my units, K cancels out and liters cancels out. My answer's in torr, but they say specifically they want the answer in ATM, so you should have did the one more step. Torr to ATM. 1 ATM is equal to 760 torr. Now I can plug it into the calculator. 760 times 18.2 times 353 divided by 15 divided by 368 divided by 760, and I got 1.16. 16 ATM, and there's my answer right there. All right, the very last law that you're going to learn about is Avogadro's law. And in Avogadro's law, it is the relationship between volume and the molecules, or the number of moles. If I have more molecules inside of there, I should have a greater volume, okay? Because the molecules are going to push up the piston that's here. They are directly related, so as the volume goes up, then the numbers of moles should also go up. So if I add moles to it, the volume should get bigger. And that makes sense. When I'm blowing up a balloon, I'm adding moles to the balloon, it gets bigger. So let's try doing a problem. A 0.150 moles of helium. Moles is going to be represented with the letter N. This will be N1 of helium gas. Has a volume of 3.60 liters, volume 1. If an additional, oh, that's a key word, 0.250 moles of helium is added, what would be the new pressure, the new volume, I'm sorry. Volume 2 is going to be, since it was added to it, the total volume would be 0.400 moles. Because I added it to it, I have twice as many. So let's go back to our equation. V1 divided by N1 is equal to V2 divided by N2. So let me write my equation. V1 over N1 is equal to V2 over N2. They're looking for the new volume, so I'm going to cross multiply volume 1 moles 2 divided by moles 1. It's equal to volume 2. Plugging it in, volume 1 I said was 3.60 liters. Moles 2 is 0.400 moles. Divided by moles 1, which is 0.150 moles. Okay. Plugging it in, moles cancels out. My answer's in liters, so I'm going to multiply and then divide. 3.60 times 0.4 divided by 0.150, and I got 9.6. Well, I need 3 sig figs, so I'm going to add one more 0. 9.60 liters, and there's my answer. All right, last question. So for this one, it says a 0.350 mole, that's moles 1, of hydrogen occupies a volume of 8.50, volume 1. Of hydrogen gas was added until the volume reached 20 liters, volume 2. How many moles of hydrogen do you have now? All volumes are measured at the same temperature and pressure. So I have volume 1, moles 1 is equal to volume 2, moles 2. I'm looking for moles number 2. So I'm going to cross first, volume 2, moles 1, divided by this side, volume 1 is equal to moles number 2. Plugging it in, volume 2 is 20.0 liters, times moles, which is 0.350 moles, divided by volume 1, which was 8.50 liters. Looking at this, liters cancels out, so my answer's in moles. So I just multiply and then divide. 20 times 0.350 divided by 8.50, and I got 0.824. And there's my answer right there. Okay, so you're done. There's a practice there. Make sure you watch the video before the practice so you know how to do the practice. And it's going to be 10 questions. You have 2 days to do this, so don't feel like you have to rush today, but you do have 2 days to complete the assignment.